Greetings. As I mentioned in the previous YouTube clip, we're now going to discuss how the examples that I just used in order to demonstrate the selection of the correct t-value, I'm going to demonstrate, or I'm going to demonstrate how the distribution, the t probability distribution, would look on paper if we were asked to draw or chart the information. So let's use this first example. N equals 20, 95% confidence intervals. All right? N equals 20, 95% confidence intervals. What that 95% means, is that we are going to account for, or we're going to need to account for, 95% of the probability distribution, the t probability distribution. So for example, all right, let me draw this picture. I'm simply drawing the bell-shaped curve. Oops, there we go. Pretty good. That is a representation of the t probability distribution. Oh, by the way, how much area is under that curve? How much? 100%. Or expressed as a proportion, 1.000. All, in other words, this is all the area underneath this curve is 100%, all of it. So, what we're wanting to do is to create a drawing and chart information that accounts for 95%. So in other words, this whole piece right here that I'm drawing the pen around imperfectly is 95% of it. Okay, now here's a question for you. If this piece is 95%, how much does this piece have to be, and how much does this piece have to be? Let me start by saying this. How much are both of these pieces together? If you said 5%, you are correct. Because if this is 95%, and due to the property of symmetry, we know that what's left has to be 5% total. So if we know that each of these two pieces that I'm stretching my forefinger and thumb to point to, if we know that both these pieces together are a total of 5%, how much does each piece have to be separately? What do you think? If you said 2.5%, you are correct. And guess what? Here's a little addition for you. What's 2.5% plus 95% plus 2.5%? You got it, 100%. Now, N equals 20, 95% confidence intervals. I'm going to add some information to this drawing. N equals 20, which means degrees of freedom, n minus 1 equals 19. We are discussing, even though we haven't actually done it yet, 95% confidence intervals, which means our t-value equals, let's see, degrees of freedom 19, 95% confidence intervals, 2.093. 2.093. Now, that's what I just added to this drawing. This is the same drawing. Normal t probability distribution, 95% chunk in the middle. Why 95%? Because we're building 95% confidence intervals, or that's what we're moving towards, which means this piece and this piece together have to be 5%, or 2.5% each separately, right? Okay, and here I've just created, you know what I like to call this? I don't know. Does anyone use maps anymore? Or they just use Google Maps or whatever? I like to call this a legend, right? This is we're orienting ourselves. It's like a map, right? And a legend, you use a legend to help yourself interpret a map. The t-value is 2.093, but here's the trick. Here's the only other thing we need to add to this drawing to make it complete are the t-values, and I'm going to show you where they go. T equals 2.093 on the right, t equals negative 2.093 on the left, and I'm just drawing a quick stripe down the middle. Check out what I added. Really not that much. A t-value of negative 2.093 on the left. Yes, t-values can be negative just like z-values can be negative, and a t-value of 2.093 on the right. What are t-values? They are units of standard error. What are these t-values in particular? They came from the table, right? That's where I didn't just pull 2.093 out of my hat, as it were. I pulled it from the t-table. Sample size of 20, 95% confidence intervals means that we could expect 2.093 units of standard error to occur by chance alone. That's what this would look like on paper. All right? A bell-shaped curve with a 95% chunk in the middle, 2.5% chunks on the edges. The legend here, n equals 20, df equals 19, 95% confidence intervals, t of 2.093, and then our t values down here. T of negative 2.093 on the left, t of positive 2.093 on the right. All right, I'm going to go ahead and upload this one, and I'm going to do another example, the next one that we